one of this is the IC that controls this MOSFETs. Also, we have two MOSFETs in the other side, okay? So one of this controls this MOSFETs in order to give 3 volt and 5 volt. So how can we know which of this controls this MOSFETs? Easy. So let's first unplug the adapter and let's put the multimeter to the buzzer option. Okay, let's check if we set the continuity correctly. Okay, let's check which one of this IC is responsible for controlling this MOSFET. So easy, you should just go to the gate of one of these MOSFETs. So put one probe into gate of one of these MOSFETs, okay, and check this IC. You should hear a buzzer, a continuity. Okay, let's check this. Okay, let's check this also. Remember, this probe is in the gate of this MOSFET. So let's check this. Now buzzer. Let's check this side. Okay. As you see in the multimeter, so this pin here is connected directly to this gate. So let's check this gate also. So here we have the source, here we have a gate. So let's check this MOSFET also. Okay, let's check this side. Here. It's okay. As you see. Also, so this, the gate of this MOSFET, as you can see, is connected to this pin here. So as you can see here, we have 8744A, the maxim 8744A. This is the IC that controls these two MOSFETs. Okay, so this is the 3.3 volts and 5 volt circuit. We have this MOSFETs and these two inductors, and also we have other MOSFETs in the other side, as you can see. Okay, this MOSFET, this is the back side of the 3 volt 5 volt power circuit. This MOSFET doesn't receive any control signal in the gate, means maybe the problem in this IC. So let's check its reference. As you can see, maxim 8744A. So let's go to the computer and look for the circuit diagram of this IC maxim 8744. Okay, in order to know about its pin configuration. Okay, so let's see the computer. Okay, so you can just go to Google. Okay, so let's write max 8744A. Okay, so maxim or max, no problem. Data sheet. Okay, as you can see, and then press enter. So we have here, as you can see, max 8744 datasheet PDF. Okay, so let's press this link over here. So here, as you see, in the search box, we have max 8744, and also here we have download. So let's press this. Okay. So as you see, now we have the file. The file is about 36 page. Okay, so let's see the title. So here we have, as you can see, okay, so this is a high efficiency quad output main power supply controllers for notebook computers. Good. I have here max 8744 and max 8745. So this reference is interchangeable with this. So the max 8745 is the same as max 8744. For example, if you find that the max 8744 IC is bad, you can change it or replace it with max 8745. Yeah. So here we have features. As you can see here, this is what we need. As you can see, we have here DL mode feedback 3.3 volt, 5 volt fixed or adjustable output voltages. Okay, so let's see the pin configuration. So let's zoom in a little bit. So as you can see here in the pin configuration of the IC, as you see, this is 8 pins. In both sides or in all sides we have 8 pins. As you see, from 1 to 8, here from 9 to 16, from 17 to 24, and from 25 to 32. So let's check in the motherboard to be sure. So as you can see, also for this IC we have 8 pin. So this is the pin number 1 because here we have this mark here, as you can see, and we have this dot here. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 pins here. We have also 8 here, 8 here, and 8 here. So 32. The same as the IC that we have in the circuit diagram. Okay? So as you see, here we will see the important signals here. As you can see, for example, here we will see just the important signal on this IC that can make the IC stop working. So as you see, we have here the shutdown. As you see, this is an enable signal, shutdown. If the signal is activated, the IC will stop working, or the power management IC will stop working. We have here ON3 or on3 means enable 3 volts. Here we have on5 means enable 5 volt. Also, these two signals are important. If the signals are absent, the 3 volt and 5 volt will not be generated. We have the reference. This is the reference voltage. This is the ground. As you see, we have the power good. This power good means the power good 5 means when 5 volt is generated with this IC, a power good signal will be generated by this IC from the pin number 4 to inform the SIO that the 5 volt is good, so the power good. As you see, here we have the drive high 5 means this is the control signal for the first MOSFET, okay, that is responsible to generate 5 volt. Here we have the drive low. As you see, drive low 5, this is the second MOSFET. Okay, here we have LX5. This is from here the 5 volt will be generated. This is the control. This is the feedback if the 5 volt is generated or not. We will see this in the schematic. Here we have the in, as you see, the V in. This is the V in for this IC. Always the in power is 19 volt. For the power management ICs, always the V in is the same voltage as voltage of the power jack. For this IC, 19 volts. Okay, we will see this. We will check this in the motherboard using the multimeter. So here we have the power good A, we have the drive low 3. Drive low 3, this is the control signal for the low MOSFET of 3 volt. Here we have LX3, this is the feedback. From here, the feedback if the 3.3 volt is generated or not. Here we have the drive high 3, okay. This is the control signal for the high MOSFET in the 3.3 volt circuit, okay. Here we have the boost tree, the power good tree. So when 3.3 volt is generated, a signal will go to the SIO from pin 27 about 3.3 volt to inform the super IO that the 3.3 volt is generated. The same for the 5 volt, okay, etc. So let's see the schematic of this IC. As you can see, you can find here many characteristics about symbol, conditions, the temperature, etc. Okay, so let's see for now the schematic of this IC. Okay, all this information are characteristics about the IC, the heat, the pinout, the resistance, etc. Okay, here also we have some some operating characteristics, some graphic information about the IC, as you can see. Okay, if you want to gather more information about power management ICs, okay, for me now I will show you the circuit diagram of the IC. As you see, here we have the circuit diagram of the IC, as you can see. So here, as you can see, this is the input. The Vin is applied to pin number 21. Okay, so remember, pin number 21 is Vin. We will check this in the motherboard using the multimeter. We will check if we have 19 volt here in pin number 1 or not. Okay, so here we have drive high 5 in the pin number 16. Okay, as you see, this is the first MOSFET, the high MOSFET. So drive high 5 to the gate, directly to the gate of this MOSFET. Also the Vin is applied here to the drain of this MOSFET, as you see. So here we have drive low applied to the lower MOSFET, as you see, in the gate. Here, as you can see, so here, so between these two MOSFETs, so the 5 volt, as you can see, 5 volt power management output will be generated here and will be applied to a coil and, as you can see, to a chemical capacitor. Okay, so this 5 volt will be also the feedback will be applied to LX5 in order to see this power management want to know if this 5 volt is generated or not. So here we have the feedback. Okay, as you can see, so we have the Vin goes through this MOSFET. As you can see, we have drive high 5 and drive high low. So the 5 volt will be generated, pass through this coil and through this chemical capacitor, and here we have, as you see, plus 5 volt power management output. So the same here for 3.3 volt power management output, as you can see. Okay, so also this Vin, as you can see, is applied also to the first, as you see, to the first MOSFET. Here, as you see, we have chemical capacitor or PF capacitor also here, as you can see. This is a filtering capacitor. Okay, so this 19 volt will be applied to this MOSFET. Here, as you see, we have drive high 3, as you can see. So this is the control signal for this MOSFET. As you see, we have here another MOSFET. We have drive low 3. This is the control signal in pin number 23. So here the 3 volt will be generated, as you can see, and pass through this coil, as you can see, L1, and then through this chemical capacitor. This is a filtering capacitor, and then we will get 3.3 volt power management output. Okay, this 3.3 volt will be applied to the super input output or super IO, and then to the BIOS, to the keyboard, to power button, okay, etc. Okay, so as you can see here, we have, as you see here, we have other signals. For example, let's see, so we have here the power gate, as you can see. So we have here the power gate 3, power gate 5. So as you see, connect to 5 volt or 3.3 volt. So when this IC generates correctly the 5 volt and 3.3 volt, as you see, this power gate 3 and power gate 5 will go to inform the SIO, as you see, power gate. So this signal will go directly to SIO to inform it that the IC power management has generated correctly 3.3 volt and 5 volt. Okay, and as you see here, this is enable signals. All these 4 signals are very important for this IC. If one of this is absent, this IC will stop working. So we have shutdown signal. We will check it in the motherboard using the multimeter. We will check the shutdown signal. Always the shutdown signal about 3.3 volt or 5 volt. Okay, we will see all this in the motherboard. So we have the shutdown, we have the enable 3 or on 3, we have on 5 or enable 5, and we have on A. Okay. Hi. So now we're going to check this power management, as you can see here. So the Maxim 8744A, the power management that is responsible in this motherboard to generate 3.3 volts and 5 volts. So in accordance with its circuit diagram, I can draw now the important pins that we are going to check. So in accordance to its circuit diagram, so let's assume that we have here the 8744A IC. Okay, so we have the pin number 5, okay, is enable, okay, enable 3, okay, so the pin number 6 is enable signal for 5, for the 5 volts. Okay, and the pin number 8 connected to the ground. Okay, so in pin number 14, okay, we have the power grid for 5 volt, and in the pin 16, the drive high for 5 volt. Okay, this signal goes to the MOSFET, okay, to the higher MOSFET. So in pin 21, as we see, this is the V in. We should find 19 volt in this pin. Okay, so in pin 25, this pin is for drive high 3. Okay, so in pin 27, so pin 27 is the power, okay, the power grid for 3 volts. Okay, so let's check all these pins. Okay, so let's check pin number 6, 5 and 6, and pin number 8 for ground, 14 power grid, and pin number 16, 21, 25 and 27. So let's plug first the adapter. Okay, so let's plug the adapter. As you can see, now the adapter is plugged. So now we will check our IC. So let's put the multimeter into 20 volt, as you can see, 20 volt DC, and then press the power button. So let's put the black probe in the ground, any ground in the motherboard, this or this, anywhere in the motherboard. Okay, so let's check first the 19 volt, the V in. So the V in, we have V in, as you can see here, V in is in the pin 21. Okay, so let's check pin 21. So here, as you see, we have this mark, this triangle, white triangle means this is pin number 1. Okay, here we have 8 pins in this side, so we have 8. Here also we have 8, so here 16, and here we have 8 over here, so this is the last one. Here is 24. The V in exists in pin 21. Okay, so let's check 21. Okay, so here we have 17, 18, 19, 20. Here we have 21. As you can see, the multimeter 19 volts. Okay, so the pin number 21 in this IC is 19 volt. The 19 volt is present, so good. Now let's go and check these two signals, enable 3 and enable 4, enable 5, in pin number 5 and pin number 6. So here we have 1, 2, 3, 4. Here we have 5. So enable 3 is 0 volt. So 6. Let's check 6. Enable 5 is 0 volt. So the IC doesn't receive enable signal. So there is a problem. If the IC does not receive enable signal, it cannot generate 3.3 volt and 5 volts. So let's check the shutdown. So we will add here the shutdown. I forget shutdown. Okay. So the shutdown exists in the pin number 5, number 4. So the shutdown exists in pin number 4. So let's check shutdown. I forget this signal because this is an important signal. Let's check number 4. Okay. So here we have pin number 4, as you can see. So 1, 2, 3. This is pin number 4. So in pin number 4 we have 5 volt. So the shutdown is good. There is no problem. Normally if this pin is 0 means the shutdown is activated. So here we have problem in enable 3 and enable 5. If we check for now drive high 5, in pin number 16 we will find 0. So let's go to pin 16. So we have here 8. Here we have 8. So this is pin number 16. We have 0, as you can see. 0 in drive high. No signal, no control signal, because we have problem in the enable 3 and enable 5. Even if the IC is powered and the shutdown is good, we have this problem. These two signals are absent. Why? Because maybe we have problem here in the super IO, okay, or in the BIOS, but we find that the super IO is good because we check this capacitor. The super IO is good, so the problem is in the BIOS. The BIOS should be reprogrammed. Okay, there is the program of inside the BIOS is corrupted. Maybe the program is corrupted, or maybe the BIOS itself, the BIOS chip, is damaged. Okay, so the problem of this motherboard is the BIOS. That's why this IC doesn't transmit the enable 3 and enable 4, 5 volt to the power management IC that is responsible for generating 3 volt and 5 volts. Okay, so here we have another motherboard that we are going to diagnose. Okay, so as you can see here, so this is the power jack of this motherboard, as you can see, and this is the power jack cable. Here we have the connector. So let's plug the 19 volt adapter to the motherboard. Okay, so here we have our multimeter. So let's choose the 20 volt DC. Okay, and then press the power button. So let's check our connector. Okay, if we have here 19 volt or not. So we have here the ground, as you can see. Let's put the black probe here in the ground and then check this, the first pin. So let's check the first pin. As you can see, we have here 19 volt. Let's check this also. We have 19 volt. Okay, so this 19 volt normally should pass through this MOSFET. Okay, as you can see, we have here 19 volt in this MOSFET. So here, this is the gate, we have 8 volt. This is the control signal. Okay, so here we have the coil. This coil is for this battery. Here we have the charge IC. Okay, here we have the super IO or super input output. Okay, so here we have two coils. This coils, it seems that this coil is for 3.3 volt and 5 volt. So let's check. Here we have 3.3 and here we have 5 volt. Okay, so this motherboard is good right here. So here this is the CPU input output. Normally if we check the capacitor near to this SIO, we should find 3.3 volts. So let's check this. For example, we have here 19 volt. So this is an IC. This is 19 volt is the working power for this IC, the power management IC. So let's check this capacitor here. So as you see, I have here 3.3 volt. As you see here, because the 3.3 volt all is the power, the working power for this. Okay, so for this, for every power management, I see this or this, for example. Let's check this. We should find here 19 volt. As you can see, we have 19 volt because this is the power management IC. Also for this, as you can see, we have here. So here we have 9 volt. Here we have 19 volt. This is 19 volt is the power or the working power for every power management. But for this SIO or super IO or super input output IC, its power or its working power is 3.3 volts, exactly as we have here. Okay, 3.3 volts. So now here, as you can see, the power is good right here. Also, as you can see here, this is the connector for the battery. As you see, we have here 3.3 volts because the super input output responsible for the battery connector to charge the battery, also responsible for the keyboard, also for the BIOS, okay, the basic input output system, and also for power button. Okay, this IC gives 3.3 volt to the battery connector. Okay, also to the BIOS. As you can see, we have here the BIOS. So let's check the BIOS. We should find 3.3 volt normally here. So let's check. Let's check the pin number 8. So we don't have here 3.3 volt. So let's check here. 3.3, but here we don't have 3.3 volt. So there is a problem here. The BIOS should have 3.3 volt in the pin number 8. Always the BIOS should have 3.3 volt in the pin number 8. So there is a problem here. Normally the 3.3 volt should be here. Okay, this is the ICH or south bridge. Okay, so I will explain to you in a paper all about 3.3 volts. When you plug the power jack, okay, so we have a 19 volt. So this is the power jack. Okay, when you plug this power jack, this 90 volt pass through some components here, like fuse and switch or MOSFET. Okay, so this 19 volt can be passed through a fuse, okay, and through a MOSFET or a switch. Let's assume Q1, and you can find another switch, for example Q2, and then a resistance, a current resistance, PR, for example. This is a current resistance. This should be connected to a power management IC. Okay, so here we will get the main power 19 volt. Now here this 19 volt should be distributed to the whole motherboard. So this 19 volt should be distributed to the motherboard, okay, to the motherboard circuits, including processor circuit or CPU circuit, RAM circuit, 3 volt and 5 volt circuit, GMCH circuit, ICH circuit, etc. This 90 volt will be distributed to the all motherboard circuits, okay, including CPU circuit, RAM circuit, 3 volt, 5 volt circuit, GMCH circuit, ICH circuit, etc. So for the SIO, okay, so in the motherboard also we have the super IU, okay, or super input output IC, this one, okay. This SIO is powered with 3.3 volt and also gives 3.3 volt signal to many components, exactly to the keyboard. When the computer is asleep, you can just press the keyboard and then the computer will be powered on again. So 3.3 volt, the CPU input output give 3.3 volt to keyboard. Also to the BIOS chip. Okay, BIOS chip. Okay, in the pin number 8. Okay. You can find also in pin number 1 and pin number 5, etc. But pin number 8 is important. Also, the SIO gives 3.3 volt to the power button. Okay, to the power button. That's why when you press the power button, okay, when you press the power button, here, for example, connected to the ground, and here 3.3 volts. So when you press the power button, the 3.3 volt goes to ground and then the computer will powered on. So the SIO gives 3.3 volt also to the power button. Also, it gives 3.3 volt to battery connector. Okay, in order to charge battery. Okay, in order to charge battery. Okay, so the SIO has a very important roles. Okay, but for this motherboard that we have seen, the problem is here. We don't find 3.3 volt in the BIOS chip. Means there is a problem in the power rail of the BIOS chip. So the problem for this motherboard is that the BIOS doesn't get 3.3 volts. Okay. So let's check the CPU input output IC. Okay, so to check the CPU input output IC, you should first check the body of IC and also all pins of the IC. If you find something that is not normal, means there is a problem here. Okay, as you see, you should check the body of the IC. I will show you an example of a bad component. That's why we should always check the body of ICs and MOSFETs. So do you see this IC over here? Okay, this IC is bad, is damaged. That's why we have this hole here. This IC should be replaced. Okay, so this IC, as you see, is a good IC, but this is bad. That's why always you should check the body of ICs before going to check its pins and the voltage, etc. If you have a dead motherboard, you can connect the adapter, okay, to the power jack and then go and feel or check using your finger the IC. If you find that the IC is hot, is very hot, means the IC is damaged. Okay, but to be sure 100%, I will give you the secret. The secret is to check the PF capacitors around the IC. Exactly, this one does also, okay, as you can see here, and this one also, because if you find any one of this is connected to the ground, is shorted to the ground, means this IC is shorted to the ground, because always the PF capacitors or the ceramic capacitors near to this IC is connected to the power rail, not to the ground. Okay, if you find this or this, for example, or this too, or this connected to the ground, means this short, this IC is short. Let's check these PF capacitors using the multimeter. So first, put the multimeter to the buzzer option and then press the power button. So then check the continuity. Okay, so let's check this capacitor, as you see. So this is a good capacitor. If you hear a buzzer, means there is a problem. For this, also good. Let's check this too. Also good. This also is good. So if you hear a buzzer, if you check, for example, this, and you hear a buzzer like this, means there is a problem. Not in the PF or ceramic capacitor, in the SIO. Okay, so it seems that the super input output is good. Okay, so let's check around the super input output. So let's check. Okay, so all components around it are good. So the capacitors are good. Here we have this diode, good. Okay, so the BIOS. Okay, let's see. Yeah, okay, the BIOS seems not good. This is a bad BIOS. So we have here, this is a flux, means this diode is already replaced. As you can see, I don't know about this motherboard. Yeah, this is okay. This is the flux. As you see, this is a bad BIOS. So it seems that the problem is in the BIOS. This BIOS is already replaced, so it become again bad. So the problem is in the BIOS. Maybe we have to flash or to reprogram the BIOS again with its flash, or maybe the BIOS IC is bad. So this motherboard has a bad BIOS. This BIOS should be replaced, and then the problem will be resolved. Okay.